Good morning everyone, and welcome to today's worked exam answer video. Today I'm having a look at a relative atomic mass calculation where we're actually being asked to calculate a percentage abundance for one of the isotopes as opposed to the actual relative atomic mass itself. And this is a particularly tricky question because we're going to have to use algebra. The preceding parts of the question are quite nice, but I'll still talk through those as I always would. But the main focus of this video is trying to communicate how to approach a question like Part C, where you don't have information about all the percentage abundances. You need to use algebra and you need to rearrange the format of the equation that we would usually use to work out the value for whatever algebraic letter you choose. I'm going to go with X. So highlighting and annotations, and I'll come back with my worked answers in a second. So to start off, we've been asked to define the mass number of an atom, which I guarantee all of you could do in year 10. So the mass number being the total number of protons and neutrons in the nucleus of an atom, i.e. the two of the three types of subatomic particles that contribute mass towards the atom. Then we've been given a table where we've had to deduce the number of neutrons and the number of electrons for two different titanium species. We have a titanium atom and we have a titanium ion, and we've been asked to complete the table. So we've been given the mass numbers of both of them, 46 on the top and 49 on the bottom. The ion then has a charge of 2+. The top is an atom with no charge. We've been given the number of protons, which for both is 22 because they're both titanium. To get the number of neutrons, we're going to need to do the mass number take away the proton number, because protons and neutrons equals mass number, as we've just defined. So 46 minus 22 and then 49 minus 22 to get 24 and 27 respectively. And then electrons, same as the protons for the atom, so 22. And if we have a titanium 2+ ion, then 2 electrons have been lost. So we started with 22 to match the protons. We will now only have 20. I think that should all be very straightforward for all of you, but any questions, as always, please do hit me up. Like I say, this is the part of this question that I really wanted to focus on. So this is our algebraic relative atomic mass calculation, which I think 3 marks for this is pretty harsh, considering you will get 2 marks for a normal calculation of relative atomic mass from abundances and mass numbers like you would do again at GCSE. You do still get questions like that for 2 marks. Here we're only getting 3 for doing this far more difficult rearrangement. Now we're told titanium contains 4 isotopes, and I've colour-coded them. We've got the 46, 47, 48 and 49 for the 4 different mass numbers of those isotopes. We're told the relative atomic mass is 47.8, and then we've been told the ratio of abundances for 3 of the 4 isotopes, the 46, the 47 and the 49, and they're in the ratio of 2 to 2 to 1. And we have to calculate the percentage abundance of the 46 titanium isotope in this sample. Now, the good thing about them saying percentage abundance is that we know that the ratios, the 2 to 2 to 1, and the missing one for the 48 titanium need to total 100. That's going to come in very handy in a second. With regards to this 2 to 2 to 1 ratio, set 1 as X, 2 is 2X, and again, therefore, the other isotope with the ratio of 2 will also be 2X. So we have a total of 5X here, and we know that these 5X and whatever the 48 titanium abundance is will need to add up to 100%. So therefore, we can choose to write the abundance of the 48 titanium isotope as 100 minus the 5X, which are the abundances of the other 3 isotopes totaled up. We can't have an equation where we have multiple unknowns. So the biggest mistake that students make on a question like this is they would call the 48 titanium Y or any other algebraic letter that's not X. And the difficulty with that is we can't solve an equation that has 2 unknowns. because we'll get to a point where we get so many X and Y is a number, and then we wouldn't be able to go any further than that. So we always have to have all of the abundances for however many isotopes you've got, all in the same algebraic letter, so X in this case. Now, how we would normally work out our relative atomic mass calculation is to do the mass number times the abundance, add mass number times abundance, add mass number times abundance, add mass number times abundance, and then when they're percentage abundances, divide by 100, and that would get us our relative atomic mass value. So I've used the exact same equation here, subbing in 46 times 2x, 47 times 2x, 48 times 100 minus 5x, 49 times x, divided by 100 is 47.8. And then I have expanded out all of these brackets. So this one is by far and away the trickiest because we have to do the 48 times the 100 and the 48 times the minus 5x. And then I've taken the 100 from the bottom on the left side and multiplied it by the 47.8 to give me the 4,780 on the right. Got 92x, 94x, minus 240x and 49x. So I've then added all of those together and I've moved the 4,800 onto the other side because we want to group all the x's and all the numbers. And that gets me minus 5x on the left hand side equals minus 20 on the right hand side. So then minus 20 divided by minus 5 gives me a value for x equals 4. Now, I guarantee some students at that point will be so relieved that they've got an answer for X that they will fail to go back and carefully check what the question is actually asking of us. So we've been asked for the percentage abundance of the 46, and the 46 was in the 2 part of the 2 to 2 to 1 ratio. So as I wrote here, the abundance of the 46 titanium isotope is 2x. So if X is 4, the abundance of that 46 isotope is actually 8%. Now that is tricky, but there are a number of really similar sorts of questions that come up like this. If you find one and you want me to have a go at it, please do get in touch with me. You can reach out via social media or via email, and I will very happily do that. Any questions, also please send them my way. Thank you so much for watching, guys. Wishing you all a very lovely day.